So I'm going to show you how to bring up some Docker instances, how to test if these instances are connected, kind of basic sort of cluster computing stuff, and then we'll go into sort of the Python socket programming stuff. All right. I do not have Docker installed on this computer because it's too old, unfortunately, for Docker to run. So I'm going to SSH into another machine that has got Docker installed. And I'm going to do it over 2 windows so that we can have 2 machines on 2 windows kind of thing. It will make life easy to look at. Okay. Oh, sorry. Okay, so typically this is, and I have most of the instructions here. All right, and I'm just going to fire up a regular Ubuntu machine, and it's going to just grab the latest. And I often do Docker run -it is for interactive. All right, and the commands are all here. I like to give it a name so that I have a handle to refer to this running instance. All right. And let's call this just N1. I don't think I've got an N1 running. And the image I want to run is just a regular Ubuntu image. Right? And that's it. So it fired up a Docker container using the Ubuntu image, and it gave me a root shell. All right. So I'm running everything as root at this point. Okay. Problem is that this is very minimal. It doesn't give me much. I can't even check my IP address because the regular networking tools are not even there, right? So I need to install a bunch of stuff, right? And for Ubuntu, I use apt-get. -y is to say yes for all the interactive questions that they prompt you with. And first thing I do is an update. So it needs to update all its package sources and listings and whatnot. And then I want a bunch of tools. First one is IP utils ping. I like the ping tool just to check connectivity, even though I'm pretty sure it works for Docker because I've tried it many times. But that was pretty fast. IP route tools for the IP, some of the other IP tools. And since we talked about DNS the other day, I thought I'll just install some of the DNS utils to show you how DNS works. Okay, so at this point I have stuff installed, so I can do IPA, I believe, and this tells me, oh, I should really let this be in that long format, because then the line breaks are now horrible. All right, IPA tells me all the IP interfaces that I have on this computer or this container. All right, in this case I have 2. LO is just local or loopback device, and that's just my local interface. So I always have an interface that I listen to myself. All right, this is for testing, for a lot of other things. As you'll see, we actually use this for the socket programming. All right, I have an ETH0 interface. So this is again, it's simulated because it's virtualized. So this is my virtualized Ethernet interface. And for this, the important thing that you want to note is the IP address, this. All right. So in this case, I've been assigned 172.18.0.3. All right. And that's a virtual LAN, virtual local area network that Docker creates for you. All right. And actually Docker does the simulated network address translation so that this computer here I can actually access outside of this local area network. For example, okay, ping is a command that's used to test connection. All right. And most computers have a ping server, a ping echo server running. Basically means that whenever I send you a ping is like, are you alive? It's going to reply me back with something. So for example, I can ping the Unix.server, which is unix.hawaii.edu, and it's going to tell me that it's alive, right? Let's Control C. Right. So this is saying that 64 bytes from UH02 to IPS. This is the actual address, and the time it took was only 0.6 milliseconds, which is normal because it's a local server, right? If it's a remote server like www.google.com, it's going to take a lot more than 0.6 milliseconds. All right, because this actually has to go. Our nearest is probably California, so it's probably going to go across the ocean to California and back. And you saw it's about 69 or about 70 milliseconds to get there and back. Okay, so that's the so that's ping. So ping basically shows you that there is network connectivity, right? I can actually reach, my packets can actually reach the Google server. All right. NSLOOKUP is just a tool to resolve your domain names. For example, the Google server, what does it resolve to? I mean, you have it here. It's actually 216.58.93.68, right? But you can actually resolve that using NSLOOKUP, right? www.google.com. Oops. What address does this map to? And it says that it maps to 216.58.183.68. Okay, so NSLOOKUP is the tool that you use to look up the mapping between domain names and IP address. All right, now if I start up another Docker container, right, on this same machine, right, so I'm going to follow the same steps pretty much, right, these same steps, right, run, oops, -IT. I'm going to name it. Oh wait. Before I do this, right? So since I have that container running, when I do Docker PS, I should be able to see something, right? So here I have. Okay, so the first one, that's my container that I just ran. Right, I know I have a second entry there. That's the one that I was trying out yesterday. All right, and the names is N1. Okay, so I can kill this by doing a remove N1, and you will actually remove that container. Well, you got to stop it first, then you will let you remove it. All right, so there is stuff like that. You can also do look at the virtual network that the Docker set up. So network, is it LS? Let me see. Okay. So right now, I believe I'm using the default bridge. Okay, I have a bunch of virtual networks there. Some of it I created last semester, but the one called bridge, I think that's your default. All right, but you can create your own virtual network and actually attach your containers to the virtual network. All right, but we're not doing that today. All right, so I'm just going to fire up another instance, run IT dash name. I'm going to call this N2. I'm going to do Ubuntu again. Oops, what did I do? Oh, I have another container that name. Okay, sorry. I should have got rid of that one. But let's call it N3 instead. Okay, so N1 and N3 is what we're using right now. All right. So again, it landed me in this. But you realize that it's using the same image, so I have to go through the same installing of packages and stuff like that. So you can avoid that in two ways. One is you can grab the image, and Peter went through the command in class. You can grab the image that I'm running in the first container in N1 and actually store that as an image. Or you could use a Docker file and all the commands that I did, put it into a Docker file script, right? And use the Docker file to create an image and name it, say, my Ubuntu image kind of thing, right? And then you will keep running that image instead. And maybe I don't need everything, but I do need ping. And I do need IP route. Okay, so at this point I've got two containers running, one N1, one N2. And let me look at the address of this one. So slow. So this one is 172.18.0.4, right? To check if they're connected, you can send a ping 172.18.0.4, right? And of course it's connected because they're both connected on the same bridge network. Okay? So I would often do the ping test every time I bring up a cluster, just as a sanity check, just to make sure that my cluster is connected. Okay? So in a nutshell, this is how you bring up multiple containers in one computer and simulate a cluster. On top of this, now you can install, if you want to do Hadoop, you can install Hadoop. And that's a separate thing we'll do later on this class. Some of you have done it from my class last semester, or you can install some other software. Okay? Questions on this part? By the way, if you exit your containers, right? For example, I'm exiting N3, right? It is stopped, but it is the running image is still there. All right. So if you do Docker PS, N3 is no longer there, but if you do PS, is it -A or A? Then -A, right? Then I should still see N3. N3 is still here, so it exited. So you see the stage, the status is it exited. You can restart it using Docker start, right? And everything should still be there, right? Unless you actually remove this particular thing with Docker RM, which of course I'm going to do right now, Docker RM N3. In which case it would then actually remove it. So now N3 is not going to appear anymore. For that matter, I'm going to remove N2 as well, just to make my life easy. Okay, so I remove one instance. Okay.